Hello, everyone, and welcome to today's webinar. Today's webinar is a continuation of last week's. It's part two of building machine ID for milk-turn machines. And again, this will be given by Marina Vilkina. But before we start, I'd like to remind everybody that we have opened up the registration for our SolidCAM World 2020 that will take place on May 18th, from May 18th through the 20th, and it will be in Istanbul. So register as soon as you can. We have a full venue, and there's definitely plenty to do for everyone over there. So register as soon as you can. We need to know the numbers. The earlier, the better. Okay, so let's get started with the webinar. If you have any questions, just write down the questions and we will try to get to them at the end. Okay, so Marina, I will make you the presenter and you can unmute yourself and go ahead.
Thank you, Sydney. Can you see my screen? I'm in
Yes,
this
I can.
presentation.
Go ahead.
Very good. Hello and welcome to the webinar. Before I will start the second part, I would like to comment the feedback which I had got after the first webinar. The goal of the series is to show a workflow during building a machine ID file. I'm presenting this process using a set of rules developed with support team. Currently, rules are not finished and they will be changed with new functions of system itself. But now all post processors in general database will be developed, or at least will be as close as possible to the routine. From the other hand, Machine ID is a very flexible tool, and there is no the only one way to use it. If you have your own order and successful practice of use, please follow it. Things which are showed in the series is not a must, and you will decide what design will have your machine ID. We should not forget about customer needs. Customer may have some preferences in this item. Today, I will show you how to build the main structure of machine ID for Milton and Swiss type machines. Once again, it is not a must, it is a recommendation, and I'm sharing with you with my experience. I advise you to refresh your knowledge in fundamentals of Swiss type and tool mounting rules in Milton with solid webinars available on site. Today we will consider two examples, Milton and Swiss type machines from the same machine brand. Let's start from Milton machine. It's T8HY model of QuickTech machine brand. You can find rendered pictures of this machine in SolidCAM new Milton brochure. This machine has two channels and two tooling systems. First channel supports the main spindle and rotary turret motions, back spindle with rotary turret motions. It has X1, Y1, Z1, and C1 axis as the main axis, and the second channel can operate with back spindle with what we call the gantry tooling system. It has X2, Y2, Z2, and C2 axes. I will start from the machine ID file from new machine ID file, and will add all necessary axes and devices step by step. The first step that should be done in a new machine ID file is a definition of machine orientation vectors. The main rule for machine orientation vectors is that default machine view in preview window should be the same as front view of a real machine, as you can see it when you open machine's door. Now let me go to the empty machine ID file. I just added a name of the machine, and here you can see the standard assembly of the machine. It is always opens when you open a new file. What I'm going to do, I'm just say that I will have the mill-turn machine, and I will put my vectors as they should be. And how they should be. According to the previous webinar, you should notice that when we click on the button like a front view with a mill-turn machine, we should have, for example, for the mill-turn machine which had the main spindle on the left side, we should have here the z-axis, and here we should have the x-axis. So I will just change the orientation of my vectors in the machine orientation section. So I will have a 180 degrees here and minus 90 degrees here. That's all. This will be my my front view of the machine. So I'm clicking on the front and I can see the machine orientation. It should be noticed that there are machines with the main spindle on the right side, and the orientation should be different for these machines. I'm clicking save, and I would like to add a couple of comments about machine access. I mean the machine access that should be added to the machine ID file, and this is recommendations about any machine, mill-turn machine you will build. So machine access should follow parent-child relationships on the machine and should be aligned, it is preferred that they should be aligned as on the machine. It is recommended to name access as it is named on the machine and to choose access direction and as it is on the machine. Access directions will influence the sign of coordinates in machine preview window. It will not influence on the output post coordinates and will influence on figures in minimum maximum limit field of machine ID file. On the right side of the slide, you can see how access will be ordered for the particular machine. And now let me refer to the 3D machine assembly. I will use it to define positions for devices and for stations. Here I have my machine assembly, and that's what we want to get at the end. So here is my main spindle, my back spindle. It not has the opposite position according to the main spindle. It is shifted in its home position, and this is its 0 on the machine. This is my turret, and here is my gantry. I will consider later the tool post of this machine. Now we will think about the spindles of the machine. I will start to define machine ID from the main spindle and 0 assembly point. As you can see, it is here. This is my assembly point of the machine of the machine ID file and for the 3D assembly. And I should put it to the machine ID file. So I'm going back to the machine ID, and I don't want to add something here because I already have my table in the list. I just change the axis and add something to it should be like on a mill machine. So this is, as you can see on the mill-turn machine, on this machine, we don't have linear axis on the main spindle. The only axis we have here, it is Z-axis for the milling. So I will name this axis as C1, and I will put it as a rotary. It is okay, but axis vector is not okay. It will rotate around the z-axis. Minus or plus depends on the machine. You should check it on the machine and check it in the coordinates here. Then I will add a table. I already have a table. I just call it main spindle. I will use it like MS, main spindle. short name, and what I'm gonna do, I'm just expand the options and take care about, just check the coordinate system. It should be the same as the machine orientation for this machine, but what I'm gonna do, I'm just gonna shift my station coordinate system because it should be at the face of the spindle. That's how I want to see it in assembly and inside my setup window. Um, so that's all for the main spindle, and let's talk about subspindle and its coordinate system. I will need my presentation again, and here we can see a current concept which was accepted for aligning subspindle coordinate system with SolidCAM support team. Let me name advantages and disadvantages of this decision. I can name as advantages that we having this coordinate system order, we have applied the NICU standard for all post processors. Easy project exchange between machines. No complications and time spending because of checking directions in machine ID. No need to build additional coordinate system for face milling operations on a back spindle. Ability to use CAM XZ view, and no need to use backtoning operations for the subspindle. From the disadvantages, we may have a confusing situation if customer has the previously created machines with Z2 aligned as Z1, and the needness to inverse the outputted coordinates. But again, it's up to you and your customer what Z2 direction to choose. I'm going back to my machine ID file, and we'll add my subspindle. Now I have to add a new axis, and I shouldn't forget that my subspindle has two axes. It can move in x-axis and moves in z-axis. So I will need to add two linear and one rotary axis, and after that I can add a part table. So let me do this. It will be my x2 axis. It is linear, but what's about the vector? In fact, on this machine, we have the x-axis on the first channel looking on my turret. It is directed on the turret, but for the second channel, x-axis direction is similar as y-axis direction on the first channel. That is why I'm going to put here x2 direction as y according my machine orientation, basic machine orientation. So this, it will be here. After that, I will put the second axis. It will be Z2 axis. And as I said, for the machine, it may be not as for the subspindle coordinate system. It's completely different things. I mean, the direction of the axis itself and the direction of the coordinate system. So they may differ. It is okay. This is axis is aligned as it should have as on the machine. So coordinates, machine coordinates, as you can see on the machine. But your coordinates when you program may differ and may have the different sign. So I will leave it as one. It can be changed later when you check your machine. Now I would like to add the rotary axis, adding axis again, and it will be C2 axis. And it is rotary axis, and I will need to check my axis vector, and also I will put here, this is very important, a rotation point coordinates. I have it from my assembly, and of course I saved it previously to have a possibility to add it here. Now I can add my back spindle. It will be a table, and it will be like BS, back spindle. Here I will expand again and check my coordinate system. The position of the coordinate system according the assembly should be here. This is the position of my subspindle, and this face will be position of the station. So it will be shifted, and coordinate system will be rotated around the x-axis. So here I will add a rotation. We can check this. Let me just save it so it will be renewed. What I need my station. It is 124 millimeters. Okay, it is not. So let me check my coordinates again, just for a second. I will check my the position of my main spindle. It should be 0, and my machine coordinates, they're okay. This is my spindle, it's okay. Here the next step will be adding the tool table. I have my X, Z, C vectors, coordinates, and the system. Oh, I forgot about drive units. This is very important. You should add the drive units, or you wouldn't be able to add no toning, no milling operations here. This is a very common error. I will put it like directly from the drive unit. I will put it on the back spindle, and okay, now it will be okay and it will work. So there are 2 part tables on the machine, and it is time to add the first one. Let me go back to the presentation and consider a couple of questions connected with the tool tables. You know that Solid Compost database was renewed and improved. In addition to its used with people from all around the world. And I believe some of you had a situation when proved and complete post that you need had some strange variables, devices, MCO cycles, submachine names, and your customer was confused with these names too. SolidCom support team is trying to bring in something which is called standard for machine ID and GPP as well, to make it easier to exchange with posts all around the world and to not spend excessive time rebuilding them. It is still up to you and your customer, but if it is possible, follow the recommendations. Beside the names, also take care about its length, which are visible in SolidCom part project itself. For example, it is inconvenient to have a long name in turret menu or in list of submachines. Let me just show you what's going on inside the project if you will add a long name. If I'm going to my part 2 table, I can see all my turrets in a turret list, and you can see that there is not much space here, and it will be better to have the shorter name and to not have a long list of the turrets if it is possible. In this webinar, I will show you 2 machines and 2 sets of tool posts, and will explain my choice of its names and its position and the quantity of tool posts. The first tool post is quite common and frequent for mill-turn machines. It is a 12-station rotary turret. It has a BMT standard. 2 things should be noticed before I will add it to machine ID. It has 2 sides holders holders, and it is possible to have 4 tools in one holder. Turret itself has angular position. That means device coordinate system should be rotated on 15 degrees from ZY plane. I would like to remind you quickly some tool mounting rules. Tool station position in machine ID will be equal to turning tooltip 0 position in tool mounting dialog box of COM part. That means we can use delta X shift as tool overhang value for real machine or to calculate or output tool offsets. This may be very valuable information, especially for machines with small cutting zone. The second noticeable thing is tool X vector direction and default tool direction in machine ID. These values will be used in tool mounting dialog box for tool default position. I'm going back to my machine ID file, and I would like to add the turret here. I have some accesses, and I just will check their direction and names. I have my turret. The parent axis for the turret is Z1 axis, and I will add it here. I will change it on Z1, and I will change it direction. Also, I would like to change it Y. It will be Y1, and the direction for the Y is okay for now, but it will have the angular position later. And I have here X1, and it will have the angular position too. I will put I will just change the spindle type on a turret type, rotor turret type, and I would like to change its name. It will be turret. So I put it like a rotary, and I would like to take care about its position of its coordinate system. The coordinate system of turret will be put according the machine orientation. But what I know about this turret, that it has the angular position. It's a normal situation. The most of the Milton machines with rotary turrets has its turret with the angular position. It has 15 degrees from the floor plane, if I can say like that. And when I add it as a 15 degrees, I can see that that my vectors are changed for the axes. They're not, but they should. I can put it. So I should check. I should have my vectors aligned as the turret coordinate system to check the coordinates, and for the x-axis too. Now I should create my stations. What I have here, I have a special function which is called create stations. It is very useful, and I can use it. And let me stop for a moment and pay your attention on maximum position letter option. It is here. It is very important for such type of the turrets, and I will show you why. Maximum position letter means a maximum quantity of tools available for one station of current tooling system. As I said, this turret may be equipped with holders for 4 tools, and I will choose, in this dialog box, I will choose D letter, which means each of my holder can have A, B, C, and D tool mounting positions. So the number of station is 12. My radius will be 165. I don't have plane height, and I should rotate the vectors of the tools my X vector. So it should be right upper on the Z axis on the central line. And my default tool direction will be like X direction. It is standard direction for the turrets when you have your turning tool inside the turret. I will put here, as I said, the D letter to have a possibility to add 4 tools in one holder. And of course, it is driven turret, so I put here the directs from the drive unit. So this is my station, and I should check what is wrong with my. Okay, I should just move my back spindle a little bit to the rotation point. Now it looks better. Yes, it is okay now. So this is like I can see it in the front view, and this is what I can see on the top view for the machine. I will save it. Okay. Several things on a real machine. Different tools from the same holder are called with different tool offsets. For example, T1 21, T1 22, T1 23, and we can define tool position and tool position letter in trace with the system variables. So you have tool position in turret as a turret station, and tool position as a letter of the tool which is positioned inside the holder. So you can have tool position in turret like 1, and you can have 4 positions of your tool inside the holder. So it makes sense what you are choosing inside the VMID when you create stations. And you can see these positions inside the tool table inside the project. The second tool post of T8HY is a gantry. In terms of machine ID, this particular tool post can be divided on 2 parts. The upper milling block with additional rotary B axis, it is here, it can rotate. And the lower tool block without drive unit and for turning operations only. I'm talking about this block. Because I will have to add B-axis, I will divide gantry tool post on 2 tool tables. There are machine modifications without B-axis. If I have such modification, I may not need add 2 tool. I will add just 1. One of the confused questions about linear turrets is turret position. The answer on the question where I should put turret coordinate system for linear tool post is whatever you want. You may have it in zero machine position, in the first station of turret, in rotation point, or somewhere else. For this particular machine, I will put it to rotation point. I will go back to the to my machine ID file, and I will add the axis and tool post for this, which is on the axis. Let me check my assembly. So what we know about tool post? It has B-axis here, but also it can move in Y-axis. Y-axis for this for the second channel is the same as X-axis for the first channel. So it moves up and down. That's all it can do. So I will have one Y-axis for the lower block and 2 axes for the upper block, because it has a rotation axis. And I will put my turret coordinate system here on the top in my rotation point. I will add one more axis, and I will call it Y2. and it will be aligned as x-axis according their machine orientation, but it will be y-axis for the second channel. Then I will add my first linear turret, the lower turret for the machine, this one, right under the Y2 axis. And after that, I will add rotary axis, B axis, and put the turret on a B axis. I'm not going to create all the stations, it will be too long, and I would like to consider the second machine today. So I will just create a couple of stations, upper stations for the OD tools and a couple of stations for the ID tools, just to show you how to align the vectors of the tool stations. First of all, I would like to name my turrets as a linear. And I will just copy the coordinates of these turrets. It should be here. After that, I don't like to add station by station. I prefer to use the create stations. It wouldn't really make sense for this particular example because for the linear turrets, we don't have it as a rotary, we have it as a line. So it's like a line template. But here, I can't create it very clear because it is not will be a line. It will have more complex structure. I will get my coordinates for tool stations from the machine assembly. I will just add a list like empty tool stations, and I will change the coordinate inside these stations. I will add just 4 stations for this particular turret, but of course it has more stations in real life. And I will put like to see them all. I will just put the distance between this the stations, and after that I will add the real coordinates for the stations. And because my stations will have a very different coordinates, so I will have to change the vectors for all stations. Let me cancel it for a second and check the stations. I will align the coordinate stations of the turret because my x-axis here for this lower turret will be parallel to my y-axis on the first channel. This is important. I don't want to do it manually for all the stations. I will do it only for the ID stations. So I will put the rotation here, and I will have my x-axis parallel to my y-axis on the main spindle. And after that, I will use the function create stations. I will add 4 stations with, for example, 20 millimeters. And I will put my default tool direction as 1 for the x-axis. It means that my tool will be aligned as for the turning operations as we use it on a turret. And it is not driven tool type. I don't need to use the maximum position letter because for these stations, I don't have any extra holders, special holders, which can be put here with the several tools inside. So I think it will be okay. And I will expand my stations and just copy the coordinates for the stations of the linear turret. What I'm gonna do for these stations, I'm gonna change their names because this is important when you have a lot of stations. For the turret, I have it like from the 1st to the 11th, and this is as I have it on the machine. But for the linear turret, it is not so. They all have their own numbers, and they should be mentioned inside the VMID to have it inside your trays, and the customer can see this figures as they will be in reality. So I will have my tool default vector as X because it will be a OD tool. 31 will be OD tool, and I will just copy the coordinates for this tool. I can have it from the assembly, and after that I will add the second station, and I will add its coordinates. So here they are, my new stations. And I can add the ID stations, which is named as T21, but they will have the other direction of the vector. They will be aligned as for the z-axis. So I know that every time I will use the station, it will have the direction like a drill or internal turning tool. So it will be aligned for the z vector. And I will copy the coordinates to see it. And I have the 22 tool not driven and with z vector, and have its coordinates. Okay, I will stop for the linear turret. Here are my tools, and I will add my b-axis with rotary tools, rotary stations. I will add it after Y2 axis. It's a B axis, it's the only one, so I just leave it as a B, and I know that it's rotary. And what I'm gonna do else here, I will put a rotation point. It will be the same as I have it here. And of course, I should change the B vector because it will rotate around the x-axis of the machine orientation coordinate system, like this. And now I can add my last turret. It will be, I will call it like B-axis. Change it and expand. And here I will put the coordinate, the position, coordinates of the position the same as I have it in the rotation point. And do not forget that it is driven. And here I will add just the 4 stations, the one station for each side. The other stations will be just shifted from the from the upper stations. I will create the upper stations. I will click create stations again. I will put 4 stations and okay, I forgot about vector again. Okay, it's not matter for this turret, the position of the vector, because it is different for each station. I will align, sorry, I will align it, according to the z vector. So I will put here the 4 stations and 20 millimeters again, but it will be like default, it will be aligned according to the z vector, and it will have a drive unit. Now we'll expand them and change their names. I will have a T1. T1 is here. T1, 2, 3, 4, and so they named from the up to down. side. So this will be the T1. I'll just leave 1 here, and the direction is parallel to y-axis of the main spindle for this position, and I will copy the coordinates, and you will see how vectors are aligned for this position. So that's what we have here. So the default tool position will be like for the y-axis, because I have my coordinate system like a default, like I have it here. Because my y-axis for this position is what I'm gonna have on the machine, but of course it will be like a Z position inside the tool table when we will align it inside the COM project. Here I will add the position on the other edge of the block. It will be T4. Position, and here I will, okay, I will do it from the bottom because I already have the 4 here. It wouldn't let me edit. So the last one will be 10, T10. I should change it. T10 position, and I will put the coordinates for this position. And I will align it like a default tool position. It will be y-axis axis again. Let me just rotate it a little bit. And here I will have my 7 position, T7. And I will have the new position. And after that, I will check my default vectors. Let me check 1, 7, 10. Okay, let it be 2. I don't care. And here we can add the coordinates. So it looks like they spread it around my basic turret coordinate system. Now I will just check the default tool direction for all these positions. For all positions, I should have it like I have it here. It will be aligned according to the y-axis, but the vectors itself should be rotated. The coordinate systems itself should be rotated. So I can have it completed around the turret. Okay, and now it looks completed, almost completed. That's what I have here, my Z direction, and yes, it is okay now. It may be easily checked if the vectors are okay if you go to the tool table, to the list of your tools inside the project, and we'll just put the tool to the position. I think that's all with this machine, and now I got full access tree with devices. The completed machine should look like this. I have much more tool positions here, but they like shifted positions from the tool stations which I created. Now let's consider one more machine. It's a uh, it's a Swiss type machine called Minimax. There is a description of access structure from the machine manual. So we will have X1, Y1, Z1, X2, Z2, C1, C2, access linear access, and we have C1 and C2, and S3, it's not real access, it's like a drive unit on one of the tooling block. This machine is equipped country type tool post with rotating tools, spindle C-axis control, backside, sub-spindle, backside tool post. Channel 1 is fitted with main spindle with the gantry and back spindle with the gantry, and channel 2 has a back spindle and back tool post. Back tool post is here. Let's consider machine tooling system. Tooling system of Swiss type machines looks much complex in comparison with Milton machine system, but in terms of machine ID, it is still linear turret type with additional stations. One of the main questions during tool station creation is how many turrets should be added. It depends on logic you will be based on and customer preferences. For example, I do not like to have a long list of turrets and part to table. I'm trying to have less tool posts in the list. For this machine, I will add just 2 tool posts, gang and at the first channel, and back tool post for the second channel. So gang tool will have a variety of tools here. We will have the block for the OD toning. We will have the block for the side milling, for the face milling, and for the face turning operations like drilling and ID turning. And the same block will be used on the back spindle, but it will be operated on the main spindle. And the second tool post will be very simple. It can't move. The all movement is has this second spindle, the back spindle, and it has tools only for turning and for the turn drill. Let's talk about machine 0 assembly point. We were based on spindle noise for Milton machines, but it not works for the Swiss type machines because you can't even see the noise of the noise of the spindle of Swiss type machines, and it is out of cutting zone at all and visible zone of the machine. It was assumed to use OD turning tool 0 point, which is here. Because it is constant for the machine and it is used to measure distances on machine diagrams, and it is extremely important during programming. The point is located in front of guide bush. I can show it here. So this is like the cutoff tool and all OD tools, and if we will have build a line, create a line from this tool, we will find this point as a cross section with a central line of the machine. I will show it on a machine assembly. Just open my assembly, and here it is. So this is the plane which I created on a OD turret. This is how my tools will be aligned on the machine. The noise of the tool will be exactly on the cross section of this plane, and on the central line of the machine. And this is what I can have as my 0 point of all assembly. And this will be the zero, like a 0 point of the machine ID file. It will be here, and this is constant. So this distance is constant. And I will remind you that all these tools can't move by Z. We have our Z1 movement only because of the stock. I will start a new machine ID file. And save it and name it as Minimax. Okay, I still should change it as a Milton. And I have the same orientation as for the previous machine because my main spindle on the left side when I open the door of the machine, and I see it over there. So I will have the two rotations of the coordinate system. After that, I will add spindles as I did previously for the previous machine. So I will rename my axis. I will. The main difference is that I will have the additional linear axis for the main spindle because I have the Z1 axis as a stock movement. So I will add the linear axis and I will put my rotary axis under the linear axis. I will call it like a Z1. It will be linear and it will be aligned as the axis on a machine orientation coordinate system. Here I will have my C1 axis, it will be rotary, and again I will change my machine vector, and my rotation point will be 0. It's not so critical. And here I will have my main spindle. Main spindle, and I will save it. And my coordinate system will be the same as for in the machine orientation. I will not move its position. It will be 0, and I will not move any other things here beside my drive unit. So coordinate system will be the same as a 0. I have all my main spindle zeros here in this point, which is like position in the air. It seems like a position in the air, but it's a cross section of the plane of OD tool holders and the center line of the machine. Now I will add my back spindle. As for the previous machine, it has 2 linear axes and 1 rotary axis. So I will add my first linear axis. It will be X2 again. And for this machine, X2 is rotated as a Y-axis on the according to machine orientation. So X2 is moved like in this direction. I will add one more linear axis, and it will be Z2 axis, and it will have the orientation as Z1 axis on the main spindle. It only will depend on the coordinates which we would like to have inside the machine preview window, I mean the sign of the coordinates. And after that, I can add my rotary axis. It will be C2, and it will be rotary, and it will rotate around Z-axis, and I will have to copy my coordinates for the subspindle again. I will have my rotation point shifted in Y and Z. Y only because the Y-axis for the main spindle is the X-axis for the second channel. So it's a little bit confused, but you have your preview window and you can check what you have during the building coordinates. And now I can add my table. It will be like BS again. So I'm using the standard names for the tables and for the devices if it is possible. Here I will use expand button, and I will change the coordinate system position. It will be the same as for the rotation point. And here I will rotate my coordinate system, so Z2 will have the opposite vector direction. It will be not as Z1. And on a drive unit, I will apply the drive unit and apply it here. And I think that's all. I can also move the position. Of course, I can move the position of the station, but currently I created the noise of the spindle because for this machine, and it is common situation for the Swiss type machines, they don't change their chucks. They set up it when they have the assembly of the machine on the floor, and they don't change it. They change only the collets inside the chucks. So that's what I have in my spindles. Let me show you what will happen in SolidCAM setup window. Main spindle station will locate in OD tool Z0 point. So I will go back to my SolidWorks window. I will close the assembly, and I will go to the Minmax project just to show you the setup window for the Swiss type machine and what will happen with the point which I created right in front of the guide bush. So I will go to the setup, and here you can see that we have zeros in the fixture and in the part position. And here I will look from the bottom to see my stock. It is small and it is okay for the Swiss type machines. So here is my 0 point, and I have my stock ready to cut. So if I will program it as for the facing operations and position it as Z0, it will be here. And this is the true position according the coordinate system of the part. And this is constant thing for the Swiss type machines. Let me close access windows. Okay, now I will add turrets and tool stations to my machine ID file. I have the two linear axes for my linear turret. So I will change the first axis. It will be y-axis. Y1, it will be linear, and for this axis, the direction will be as for the y-axis according to the machine orientation. Here I will have my x-axis, and it will be as it is on the machine, so the vector will be according to the x-axis. After that, I don't need this axis. I will delete it. Okay, put it here. And I can create my linear turret. I will call it gang, and don't forget to make it linear. Now I will add the coordinate system for the gang. It is not really matter where you I will leave it as a 0, and I will just put the positions of the tool stations according to 0 position of the gang, and it will be the position according to the machine orientation. So if I will need some changes, I will just measure it on the assembly and put it directly. It wouldn't be a relative coordinate, it will be absolute coordinates. The orientation of the system will be the same. I will just add, I would not add all the stations. I will create several stations just to show its orientation. So I will have it with the X direction and without drive unit, I think, because the first stations, which is always created for the Swiss type machines, it's OD stations. And now I will just move my stations to its positions as it should be. First of all, I will rename it. This is the first station, 31, and it is aligned according to the Z-axis. It's, let me show you what I'm creating. It's 31 station is here. It's right opposite my 0 point. So it will be shifted only by x-axis. Other axes will not be shifted. It will be here. So like here. So I will just move it by x, 169. So this is my point. It's a basic point, and it's a 0 position, reference position of the OD turret on the machine. Now I will add the next position, and it will be T32, and it will be shifted a little bit from the previous. So I will just copy these coordinates and change a little bit in y direction. It will have minus 25 millimeters. So this is my first 2 OD stations here. Now we should think about what we will have in our tool table of the part, because the order which you will have here will be the same order which you will see inside the part project. I will show you. So for example, I will have my tools here, and this is the order of my tool stations. As you can see here, they are not ordered by their numbers. They are ordered, I order it like a logic. So this is the turning tools, and this is the milling tools. But it's up to you and your customer what order you will prefer. So I will add the next turning stations here. The next turning station will be here. So this is the lower stations on this block. I will add it as T21, and I will change its coordinates. Just copy it. And what else I should do? I should change the tools vector, because it will be aligned according to z-axis. This time it will be ID turning tool, so it will be aligned according to z-axis. The next station will be the up from the upper block. For example, it will be T1 station, which is for the radial milling. T1 station, and I will check its coordinate position of the point. I will put it here, and I have to rotate this coordinate system, because the position of the axis of the tool will be here. So this is the position of this tool block. This is my T1. What else I can do? I can check the vector. It should be aligned according to the z-axis. And I will add, I think, my last station to this assembly. It will be T3 position. This is the position for the face milling operations. It is here. It's a T3 position, and I will just copy its coordinates. And will align its vector as it was for the ID turning operations. So here it's like several stations for 4 tool blocks. OD tool block, the radial milling tool block, ID tool block, and the face milling tool block. They have more stations, but I will not add it here because it is clear how to create it. I will just shift it from the previous and change a little bit one of the coordinate. What is noticeable in this machine that the supplier named these tools from the same gantry block, but it is named with the same numbers as for the tools for the working on the main spindle. So these tools has the same numbers 1, 2, 3 as from this side. That is why I will have to add one more turret here. If this block has the different numbers, I would not do this. I would just continue to add this station in the list of gang tools. But I have to add one more turret, and I will name this turret as on the names of the tools from 1 to 3, and they will be applied on the back spindle. And after that, I will just add here I can add the coordinate system of the turret because for this tool block I can apply the linear position creation because I can apply the linear template here. So I will just put the position of the coordinate system for this block and rotate the coordinate system of this block because it has the opposite z direction for the tools according the machine tool layout. They will use the drive unit, and I will apply the station creation here, create stations command, and I put the 3 stations here. The distance between station is 31 millimeters, and I will have the default Z tool direction with a K vector, and it will be have the drive unit. All the stations will have a drive unit. That's what I can have here. So in some cases, it is very convenient to have these options. And the only thing I would like to do, I would like to rename it, but I think it is clear how to rename this drive unit. So I will leave it as station 1, but in all my posts I prefer to name it as T1. So to have it shorter. So the last tool block which we have to create is this tool block. It's the most simplest, I think, because it don't have any linear axis. It is just attached to the machine envelope, and the subspindle is moves around. So I will just add a tool, turret, right under the name of the machine. And I will call it with the numbers of tools. It's 21, 24 BS tools. And don't forget, it should be linear. You will have problems in simulation and even in tool table if you will forget to rename it as a linear, if you will leave it like a spindle. Let me expand it and check the coordinates. Here I will use the shifted coordinates for the position. I will shift it. And I will check the coordinate system of this turret because it is very important to put the right coordinate system. It is explained, the position of the coordinate system, the orientation of the coordinate system is explained in one of the webinars which I mentioned in the very beginning of the presentation. Because on the subspindle, the x coordinates will be negative for this machine and for the most of the machines. We don't need drive unit here. And what I need is the station creation. Again, I will create just a couple of stations. Okay, let it be like this. So I will rename it as a T24. And I will check the coordinate position for this tool. It will be 0, so it will be the same as for the position of the turret. It is already shifted. We have a related coordinates here. They are not absolute. And I will take care about the position of the coordinate system. Here I have my z direction, the right d direction, and my default tool direction will be the same. It should be like 1 according the z position. So it can be checked very easily on the machine during the tool mounting operations. And I will create the last one tool. It will be T21. And I will check its position. I think it should be shifted just a little bit, but by x-axis of this particular turret coordinate system. So here they are, my tool stations. Of course, I will have 2 more stations here. I should add them based on the tool shift. Now I have finished with access tree creation for today. I will continue to add submachines and channels next time. In addition, I would like to add a couple of comments about choosing station position for Swiss type machines. Let me go back to the presentation. And on the left side of the slide, you can see a picture from a machine manual. And this is something that you will not find for other machine types. It is a strong recommendation from the machine supplier how OD tools should be set up. It shows us that each tool beside cutoff tool, which is left one, it is here, should be overhang equal 25
Marina, for some reason we don't hear you.
So user can leave delta X value as 0 and automatically mount OD tooltip to the right position. And I have my last slide for today. My next note will be about attached tool blocks. One of the reasons Swiss type machines are so popular is the flexibility of its tooling system. It seems like you have only one station, but in fact you can buy one or more attachments in any time you like. It is not necessary to buy it with machine and extend facilities, and you can extend facilities of your machine with this attachments tool block. We can support this feature in Machine ID. There is no need to add all attachments available for the current machine model. Ask your customer what he has or what he's going to have. Add the station where attachment will be set inside the Machine ID, and then add all stations that may appear with attachment. It is much easier to build Machine ID in collaboration with customer and based on his requirements. That's all for today's webinar. Thank you for your attention. The next webinar will cover submachines, channels, and some MCO items.
Okay, Marina, thank you very, very much for the webinar. It was, we all know it was a little long, but it was definitely worthwhile. There's a lot of information that was a lot of good information that was passed through. Again, this webinar has been recorded, and it, like the previous webinars, it will be available on our website in the reseller areas within the next few days. Okay, everyone, take care and have a great weekend. And thanks again, Marina.
Thank you too, and have a great weekend and goodbye.